We're about to embark on an adventure that pushes against the very boundaries of physics itself, diving into one of the most captivating questions humanity has ever dared to ask. Is there a way to travel faster than the speed of light? The visuals are here for you, but feel free to close your eyes, breathe deep, and let your imagination soar at speeds that would make Einstein himself pause in wonder. Also, I'd love to know where you're listening from tonight. Drop your time and location in the comments below. Are you gazing up at distant stars, wondering if we'll ever reach them? Or perhaps you're somewhere on this pale blue dot, dreaming of the day when the space between worlds becomes as crossable as the distance between cities. Imagine for a moment that you're standing at the edge of everything we know. Behind you lies 4 centuries of scientific certainty, the elegant mathematics of Einstein, the ironclad laws that have guided every rocket, every satellite, every probe we've ever sent into the darkness. Ahead of you stretches the infinite unknown, where the rules might bend in ways we've never imagined, where the impossible might just be waiting for the right key to unlock it. Tonight, we're going to walk that edge together. We'll explore the cutting-edge theories that suggest maybe, just maybe, the universe has left us some loopholes. We'll dive into concepts so mind-bending they sound like pure science fiction, yet emerge from the most rigorous mathematics our brightest minds can devise. From warping the very fabric of space-time itself to slipping through cosmic shortcuts called wormholes, from mysterious particles that might already be breaking the speed limit to quantum phenomena that seem to laugh at Einstein's cosmic speed restrictions. But here's what makes this journey truly extraordinary. We're not just exploring abstract physics tonight. We're investigating the very real possibility that humanity might one day slip the bonds of our current cosmic prison. Because right now, with our fastest rockets, it would take us over 4 years just to reach the nearest star. The center of our own galaxy lies 26,000 years away at light speed, and the nearest major galaxy, Andromeda, would require a journey of 2.5 million years, even if we could somehow travel at the ultimate cosmic speed limit. These aren't just numbers. They represent the cruel mathematics of cosmic isolation. Under our current understanding of physics, the universe might as well have built walls around every star system, every galaxy, every cluster of matter in the cosmic web. We're trapped not by physical barriers, but by the fundamental structure of space-time itself. Yet tonight, we're going to discover that some of the most brilliant physicists on Earth believe these walls might not be as solid as we once thought. We'll meet the scientists who are seriously proposing ways to bend space-time like a cosmic shortcut, who are designing theoretical engines that could compress the distance between stars, who are exploring whether the quantum realm might offer passages through the very foundations of reality. This isn't science fiction anymore. These are peer-reviewed papers, published research, mathematical models that suggest the impossible might just be improbable. We're living in an extraordinary moment in human history where the boundary between science fiction and scientific possibility is becoming beautifully blurred. But before we dive into these mind-expanding possibilities, we need to understand exactly what we're up against. Why is the speed of light such a formidable barrier in the first place? What makes this particular velocity so special that it seems to govern the very structure of cause and effect throughout the cosmos? The speed of light isn't just fast. At roughly 300 million meters per second, It represents something far more fundamental than mere velocity. It's the speed at which space-time itself operates, the rate at which information can propagate through the universe. The cosmic speed limit that ensures causes precede their effects and prevents the logical paradoxes that would unravel reality itself. When Einstein first revealed this limit in his theory of special relativity, he wasn't just describing a property of light. He was uncovering a basic architectural feature of existence. Space and time, he showed us, aren't separate entities, but are woven together into a single fabric called space-time. And that fabric has certain built-in properties, certain rules about how quickly changes can ripple through it. Think of it like this. Imagine the universe as a vast cosmic computer processing the state of every particle, every field, every interaction throughout space and time. The speed of light is the clock speed of this cosmic processor, the maximum rate at which the universe can update itself from one moment to the next. Reality doesn't change instantaneously everywhere at once. It updates at exactly the speed of light, spreading outward from each event like ripples on an infinite pond. This creates what physicists call light cones, beautiful geometric structures that describe the limits of causality itself. Picture yourself at the center of an expanding sphere of influence. Everything inside that sphere can potentially be affected by something you do right now. Everything outside remains beyond your immediate causal reach, protected by the cosmic speed limit that keeps reality logically consistent. But here's where our story takes its first fascinating turn toward possibility. While Einstein's relativity prevents objects from moving faster than light through normal spacetime, it doesn't necessarily prevent spacetime itself from being manipulated. And that distinction, subtle as it might seem, opens the door to extraordinary possibilities. In 1994, a Mexican physicist named Miguel Alcubierre made a discovery that would forever change how we think about faster-than-light travel. Working with Einstein's own equations, Alcubierre found something remarkable: a mathematical solution that would allow a spacecraft to effectively travel faster than light without ever locally exceeding that cosmic speed limit. The Alcubierre drive, as it came to be known, works on a principle so elegant it takes your breath away. Instead of pushing a spacecraft faster and faster until it hits that impenetrable light speed barrier, the drive would manipulate spacetime itself. It would contract space in front of the vessel while expanding space behind it, creating what physicists call a warp bubble. Imagine you're standing on a moving walkway at an airport. You're not walking any faster than normal, but the walkway itself is carrying you forward at additional speed. The Alcubierre drive would create something similar in spacetime itself. The spacecraft would sit comfortably in a region of flat, normal space, never locally exceeding light speed. But that entire region would be carried forward by the expansion and contraction of space-time around it. From the perspective of someone inside the warp bubble, the journey would feel perfectly normal. No crushing acceleration forces, no time dilation effects, no approach to infinite mass that normally prevents faster-than-light travel. The crew would be in free fall, experiencing normal physics, while space-time itself does all the work of getting them to their destination faster than light could travel through normal space. The mathematics of this concept are breathtakingly elegant. Alcubierre showed that such a drive would satisfy Einstein's field equations, the very foundation of general relativity. It wouldn't violate the theory that gives us our cosmic speed limit. Instead, it would use that theory's own flexibility to circumvent the limit in the most sophisticated way imaginable. But here's where the story gets even more intriguing. The original Alcubierre drive concept required something that doesn't exist in our current understanding of the universe: exotic matter with negative energy density. Matter that weighs less than nothing, that pushes instead of pulls, that behaves in ways completely opposite to everything we've ever encountered. For years, this requirement seemed to doom the concept to the realm of pure speculation. How do you build an engine that needs materials that probably don't exist? How do you harness energies that might be fundamentally impossible? Yet recent breakthroughs have begun to chip away at even this seemingly insurmountable obstacle. Physicists have discovered that the quantum vacuum, that seething foam of virtual particles that fills even empty space, can indeed produce negative energy under certain carefully controlled conditions. The Casimir effect, demonstrated in laboratories around the world, shows that we can create regions of space with less energy than the vacuum itself. Even more remarkably, researchers have begun developing new models for warp drives that require far less exotic matter than originally thought. Some proposals suggest that the negative energy requirements could be reduced to manageable levels. Others propose using entirely different mechanisms, floating bubbles of spacetime rather than traditional spacecraft moving through manipulated space. NASA itself has taken notice of these developments. Their Advanced Propulsion Physics Laboratory has been conducting real experiments, trying to detect the tiny spacetime distortions that might indicate the first steps toward warp drive technology. They've built interferometers sensitive enough to measure the microscopic warping of space itself, searching for any hint that we might be able to generate the effects Alcubierre described. The implications of success would be staggering. A journey to Alpha Centauri, our nearest stellar neighbor, could take weeks or months instead of years. The center of our galaxy could become accessible within a human lifetime. Even other galaxies might fall within reach of our expanding cosmic civilization. But the Alcubierre drive isn't the only pathway being explored by serious physicists. Another possibility lies in the strange quantum mechanical phenomenon of wormholes. These hypothetical tunnels through spacetime could provide shortcuts between distant regions of the universe, allowing effective faster-than-light travel without requiring anything to actually move faster than light. The concept emerged from Einstein's own equations, developed further by physicists like Ludwig Flamm and later by Einstein himself, working with Nathan Rosen. They realized that the mathematics predicting black holes also suggested the possibility of their opposites, white holes, connected through the very fabric of space-time itself. Imagine space as a flat sheet of paper. Normally, traveling from one point to another requires moving across the surface. But if you could fold that paper and poke a hole through both layers, you could travel between those points through the hole rather than across the surface. The distance through the wormhole might be far shorter than the distance across normal space. A spacecraft entering such a wormhole could emerge at its destination, having traveled faster than light would through normal space, yet never locally exceeding the speed of light during the journey. It's the ultimate cosmic shortcut, a way to cheat the distance without cheating the speed limit. Of course, wormholes face their own formidable challenges. They would likely be unstable, collapsing before anything could traverse them. They would require exotic matter to keep them open. And even if they existed naturally, Finding and navigating them would present unprecedented technical challenges. Yet the mathematics suggests they're possible, and if possible, they might be engineered. Some theories propose that sufficiently advanced civilizations could create artificial wormholes, cosmic tunnels connecting distant parts of the universe like a vast transportation network spanning the galaxies. As we continue our journey through these mind-expanding possibilities, we'll discover that the universe might be even stranger than these theories suggest. We'll explore particles that might already be traveling faster than light, quantum effects that seem to transmit information instantaneously across cosmic distances, and entirely new models of spacetime that could revolutionize our understanding of what's possible. The road ahead promises to challenge everything we thought we knew about the fundamental nature of reality itself. We're about to venture into territory so strange that even the physicists exploring it sometimes pause to question their own sanity, because hidden in the quantum realm, there might already be particles that laugh at Einstein's speed limit, racing through the cosmos at velocities that should be impossible. These hypothetical entities are called tachyons, and they represent one of the most fascinating paradoxes in modern physics. First proposed in 1967 by physicist Gerald Feinberg, tachyons would be particles that exist in a perpetual state of faster-than-light motion, not particles that accelerate past the light barrier, but particles that were born moving faster than light and can never slow down to normal speeds. The mathematics behind tachyons is beautifully twisted. While normal matter requires infinite energy to reach light speed, tachyons would require infinite energy to slow down to light speed. They exist in a mirror universe of physics where everything we consider normal is reversed. Add energy to a regular particle and it speeds up. Remove energy from a tachyon and it speeds up even more. Imagine trying to catch something that moves faster the less energy it has. It's like chasing a shadow that races away from you the moment you stop pursuing it. Tachyons would inhabit a realm where the usual rules of cause and effect become beautifully tangled, where effects could potentially precede their causes, where the arrow of time itself might point in unexpected directions. The implications are staggering. If tachyons exist, they could theoretically be used to send signals faster than light. Information could travel backward in time. The rigid structure of causality that keeps our universe logically consistent could develop cracks that allow glimpses of futures that haven't happened yet, or pasts that are still unfolding. But here's where the story becomes even more intriguing. Despite decades of searching, no one has ever detected a tachyon. They remain tantalizingly theoretical, mathematical ghosts that haunt the equations, but refuse to materialize in our experiments. Every time physicists think they've glimpsed evidence of faster-than-light particles, closer examination reveals more mundane explanations. Yet, the absence of evidence isn't evidence of absence. Recent theoretical work has begun to address the paradoxes that once made tachyons seem impossible. Physicists have discovered that by carefully considering the boundary conditions of quantum processes, by accounting for both the past and future states of tachyonic systems, the mathematical contradictions can be resolved. This breakthrough suggests that tachyons might exist in a subtle form we haven't yet learned to detect. They might be woven into the quantum foam that underlies all of spacetime, contributing to the strange properties of the vacuum itself. They might be the missing piece in our understanding of how information and causality truly operate at the deepest levels of reality. As we drift deeper into these quantum mysteries, we encounter another phenomenon that seems to mock our cosmic speed limit. Quantum entanglement, that spooky action at a distance that troubled Einstein so deeply, appears to connect particles instantaneously across arbitrary distances. When two particles become quantum entangled, they share a mysterious connection that transcends space and time. Measure the spin of one particle, and its entangled partner instantly assumes the corresponding opposite spin, no matter how far apart they are. Change the quantum state of one, and the other responds immediately, as if the space between them simply doesn't exist. Recent experiments have shown that this quantum connection operates at speeds at least 10,000 times faster than light. The entangled particles seem to communicate through channels that bypass the normal structure of space-time entirely. It's as if they share a secret dimension where distance has no meaning, where cause and effect can operate outside the constraints that bind everything else in the universe. Einstein called this phenomenon spooky action at a distance because it violated his deep intuition about how reality should work. Information, he believed, should not be able to travel faster than light under any circumstances. The idea that particles could maintain instantaneous connections across cosmic distances suggested that quantum mechanics was incomplete, that hidden variables must exist to restore the sensible order of cause and effect. But decades of increasingly sophisticated experiments have confirmed that entanglement is real and operates exactly as quantum theory predicts. The particles aren't sending signals to each other through normal space. They're connected by something far stranger, a quantum correlation that exists outside the normal flow of space-time. This discovery has profound implications for our understanding of faster-than-light phenomena. While entanglement can't be used to send information faster than light in the classical sense, it reveals that the universe contains channels of connection that operate beyond our normal speed limits. It suggests that space-time itself might be more flexible, more permeable than we ever imagined. Some physicists now propose that these quantum connections might be harnessed for faster-than-light communication or even travel, if consciousness itself operates through quantum processes. As some theories suggest, then perhaps our minds could learn to navigate these mysterious channels that connect distant regions of space-time. The implications stretch beyond mere transportation. Quantum entanglement might represent our first glimpse of a deeper layer of reality, a quantum substrate that underlies the apparent separation between objects in space and time. In this view, the speed of light limit applies only to the surface layer of existence, while deeper quantum connections operate by entirely different rules. But perhaps the most mind-bending possibility lies in recent discoveries about the nature of space-time itself. Advanced theoretical physics is beginning to suggest that our familiar 3 dimensions of space and 1 dimension of time might be just the visible surface of a far more complex underlying structure. String theory, that ambitious attempt to unify all the forces of nature, requires the existence of additional spatial dimensions beyond the 3 we can perceive. These extra dimensions might be curled up so tightly that we can't detect them directly, but they could provide pathways for faster-than-light travel that bypass our normal space-time entirely. Imagine trying to understand the behavior of ants crawling on the surface of a garden hose. From the ant's perspective, they can only move forward or backward along the length of the hose. But if one ant could somehow access the circular dimension around the hose's circumference, it might be able to take shortcuts that seem impossible from the limited two-dimensional perspective of its fellow ants. Similarly, if we could learn to manipulate these hidden dimensions of space, we might discover shortcuts through the cosmic landscape that make faster-than-light travel not just possible, but inevitable. The vast distances between stars might collapse into manageable journeys when viewed from the perspective of higher dimensional space. Recent research has proposed that by manipulating the 10th spatial dimension predicted by string theory, we might be able to alter the flow of dark energy itself. This mysterious force that drives the accelerating expansion of our universe could potentially be harnessed to create bubbles of altered spacetime around spacecraft, allowing them to surf the cosmic expansion like boats riding an ocean current. The energy requirements for such manipulation would be staggering, perhaps requiring the entire output of a star. But the theoretical framework exists, written in the elegant mathematics that govern the deepest levels of reality. What seems impossible today might become routine engineering for civilizations that master these fundamental forces. Even more intriguing are recent proposals for what physicists call superluminal observers. These hypothetical beings would exist in reference frames moving faster than light, experiencing a universe where the normal relationships between space and time are inverted. From their perspective, our subluminal world would appear as strange and exotic as their realm appears to us. The mathematics describing superluminal observers suggests they might perceive 3 dimensions of time and only 1 dimension of space. Their reality would unfold according to rules so different from ours that communication between our realms might be impossible. Yet the equations suggest that such observers could exist. Inhabitants of a mirror universe where everything we consider fundamental is beautifully reversed. These discoveries are converging toward a revolutionary understanding of spacetime itself. Rather than the fixed stage upon which cosmic events unfold, spacetime might be more like a dynamic ocean with hidden currents, secret passages, and depths we've never explored. The speed of light might govern only the surface waves, while deeper currents flow according to entirely different principles. As we continue our journey through these expanding possibilities, we'll discover that the boundary between science and what we once called magic is dissolving before our eyes. The universe is revealing itself to be far stranger, far more flexible, and far more full of hidden pathways than our ancestors ever dared to imagine. The question isn't whether faster than light travel is possible. The question is which of these remarkable pathways will first carry us beyond the speed limit that has confined us to our tiny corner of the cosmic ocean. The future of human exploration might depend on learning to navigate realms where the impossible becomes merely improbable, where the speed of light transforms from an impenetrable barrier into just the first of many cosmic speed limits waiting to be transcended. Tonight, as you rest under the same stars that ancient humans gazed upon with wonder, remember that those distant lights might not be as unreachable as they seem. Somewhere in the quantum foam, in the hidden dimensions, in the strange mathematics of curved space-time, pathways might be waiting that will one day carry our descendants among the stars at speeds that would seem magical to us today. The universe has spent billions of years preparing these secrets for us to discover. Our journey into the impossible has only just begun. As we drift deeper into this cosmic mystery, we encounter one of the most promising developments in faster-than-light research, Scientists at NASA's Advanced Propulsion Physics Laboratory have been quietly working on something that sounds like pure science fiction, yet emerges from the most rigorous physics imaginable. They're building what they call a warp factory, a computational toolkit designed to test and refine the mathematical models that could one day power real spacecraft beyond the speed of light. This isn't theoretical speculation anymore. These researchers are using sophisticated computer simulations to model how spacetime itself might be engineered, manipulated, and controlled. They're designing virtual experiments to test different configurations of exotic matter, different geometries of space warping, different approaches to creating the bubbles of curved space-time that could carry us faster than light. What they've discovered is both humbling and inspiring. The energy requirements for traditional warp drives remain staggering, often requiring more mass energy than exists in our entire solar system. But newer models are beginning to chip away at these seemingly impossible demands. Some configurations require significantly less exotic matter. Others propose using naturally occurring phenomena like the quantum vacuum fluctuations that permeate all of empty space. Perhaps most remarkably, some of these new models suggest that warp bubbles might be created without requiring any exotic matter at all. Instead of using hypothetical substances with negative energy density, these designs would manipulate the geometry of normal spacetime, using only positive energy. It's like discovering that you can dig a hole not by removing dirt, but by convincing the ground itself to curve inward. The mathematics behind these breakthrough concepts involves what physicists call floating bubbles of spacetime, rather than traditional spacecraft moving through manipulated space. Imagine space itself becoming fluid, with bubble-like regions that can move independently of the surrounding cosmic medium. A spacecraft wouldn't travel through space so much as it would become part of a moving region of space that carries it along like a leaf on a flowing river. These floating spacetime bubbles could theoretically achieve any velocity, even speeds far exceeding light, without ever violating the fundamental laws of physics. The bubble itself would move faster than light through the surrounding spacetime, but everything inside the bubble would experience completely normal physics. No time dilation, no mass increase, no crushing acceleration forces. From inside such a bubble, the journey to the nearest star might feel like a pleasant cruise lasting mere weeks or months. The crew would experience normal gravity, normal time flow, normal everything, while outside their bubble, the vast distances of interstellar space collapsed into manageable proportions. But here's where the story takes an unexpected turn toward the practical. Some physicists now believe we might not need to wait for exotic technologies to test these concepts. The same quantum effects that create the Casimir force in laboratory experiments might be scalable to larger applications. We might be able to create microscopic warp bubbles using techniques that are extensions of experiments we're already conducting. These tiny distortions of spacetime wouldn't carry spacecraft anywhere, but they would prove that the fundamental principles work. They would demonstrate that spacetime can indeed be manipulated in the ways these theories predict. And once we've proven the concept works on small scales, the path toward larger applications becomes a matter of engineering rather than fundamental physics. The timeline for such developments remains uncertain, but some researchers suggest that prototype warp bubble generators might be possible within decades rather than centuries. Not the massive star-spanning engines of science fiction, but small-scale proof of concept devices that bend space-time in measurable ways. Meanwhile, other researchers are exploring entirely different approaches to faster-than-light travel that sidestep the exotic matter problem altogether. One of the most intriguing involves what physicists call traversable wormholes, cosmic shortcuts that could connect distant regions of space through naturally occurring or artificially created tunnels in spacetime. The beautiful thing about wormhole travel is its elegant simplicity. You don't need to manipulate spacetime around a spacecraft. You don't need exotic matter or impossible energies. You simply need to find or create a shortcut through the fabric of reality itself. Step through one end of a wormhole and emerge instantly at the other end. Having traveled faster than light could make the journey through normal space. Recent theoretical work has shown that stable, traversable wormholes might be possible using far less exotic matter than previously thought. Some models suggest that the quantum vacuum itself, properly manipulated, could provide the negative energy needed to keep wormhole throats open long enough for passage. Even more intriguingly, some physicists propose that wormholes might already exist naturally throughout the universe, remnants from the quantum fluctuations that occurred during the universe's inflationary period. These primordial wormholes could be microscopic, but they might be detectable and potentially enlargeable using advanced technologies we're only beginning to imagine. The search for natural wormholes has become a serious area of research. Scientists are looking for the subtle gravitational signatures that might indicate wormhole mouths, the characteristic patterns of light bending that could reveal shortcuts through spacetime. Some researchers even suggest that certain astronomical phenomena we can't currently explain might actually be evidence of natural wormhole activity. If such cosmic shortcuts exist, learning to navigate them would transform humanity's relationship with the universe itself. The galaxy would become our neighborhood. Other galaxies would become distant continents rather than unreachable alien realms. The vast scales of cosmic distance that currently confine us to our tiny solar system would collapse into a navigable network of interconnected spaces. But perhaps the most mind-expanding possibility lies in recent discoveries about the nature of information itself in quantum systems. Physicists are beginning to understand that information, not matter or energy, might be the most fundamental aspect of reality. And information, it turns out, might not be bound by the same speed limits that constrain matter and energy. Quantum information already demonstrates properties that seem to transcend normal space-time limitations. Entangled particles maintain correlations that operate faster than light. Quantum states can be teleported instantaneously across arbitrary distances. The boundaries between separate quantum systems become beautifully blurred in ways that suggest deeper connections than classical physics ever imagined. Some researchers now propose that consciousness itself might operate through quantum information processes that naturally transcend light speed limitations. If our minds are quantum systems, as some theories suggest, then perhaps we already possess the ability to access faster than light information channels. We simply haven't learned to recognize or utilize these capabilities. This possibility opens extraordinary avenues for exploration. Rather than building massive engines to propel spacecraft faster than light, we might learn to project consciousness itself across cosmic distances. Instead of sending our bodies to distant stars, we might send our awareness, our curiosity, our capacity for wonder and discovery. Such quantum consciousness transfer wouldn't violate any known physical laws, because consciousness might already operate through quantum channels that exist outside normal space-time. We would be learning to use capabilities we already possess, rather than developing entirely new technologies. The implications stretch far beyond transportation. If consciousness can navigate quantum information channels that transcend light speed limitations, then communication with distant civilizations might be possible even across galactic distances. The universe might already be filled with conscious entities exchanging information through quantum networks we haven't learned to detect. Even more remarkably, quantum consciousness transfer might allow us to explore not just distant locations, but alternate realities, parallel universes, different branches of the cosmic wave function that quantum mechanics suggests might exist alongside our own experienced reality. Recent research in quantum foundations suggests that every quantum measurement creates branching universes where every possible outcome occurs. If consciousness can navigate these quantum branches, then faster-than-light travel becomes just one aspect of a far grander exploration. We might learn to visit not just distant stars, but alternate versions of those stars in parallel cosmic histories. As these extraordinary possibilities converge, we're beginning to glimpse a future where the speed of light transforms from an impenetrable barrier into merely the first of many cosmic limitations waiting to be transcended. The universe is revealing itself as far more permeable, far more navigable, far more full of hidden pathways than we ever dared imagine. The children born today might grow up in a world where interstellar travel is routine, where other galaxies are vacation destinations, where the vast cosmos becomes humanity's playground rather than our prison. They might navigate realities we can barely conceive, using capabilities that exist at the intersection of consciousness and quantum mechanics. But even as we explore these expanding frontiers of possibility, we must remember that every breakthrough brings new mysteries, new questions, new horizons beckoning us toward ever deeper understanding. The journey beyond light speed might be just the beginning of adventures that stretch into realms where physics and consciousness merge into something we don't yet have words to describe. Tonight, as you settle into the gentle rhythm of your breathing, remember that you're part of this cosmic story unfolding. The atoms in your body were forged in stellar cores. The thoughts in your mind might operate through quantum processes that naturally transcend space-time limitations. You are not separate from these cosmic mysteries, but intimately connected to every possibility we've explored together. The speed of light might govern the surface of reality, but deeper currents flow according to principles we're only beginning to discover. In those hidden depths, pathways might be waiting that will carry us beyond every limitation we currently imagine, into adventures that transform the impossible into the inevitable. The exploration of faster-than-light travel leads us into territory so profound that it challenges our most basic assumptions about existence itself. As we float deeper into these cosmic mysteries, we encounter phenomena that suggest the universe might be operating according to principles far more exotic than anything we've previously imagined. Consider for a moment the strange behavior of space itself during the earliest moments of our universe's existence. During cosmic inflation, that brief period, less than a trillionth of a trillionth of a trillionth of a second after the Big Bang, space expanded exponentially faster than light. Not objects moving through space, but space itself stretching at velocities that dwarf our cosmic speed limit by incomprehensible factors. This inflationary expansion didn't violate relativity because nothing was actually moving through space-time faster than light. Instead, space-time itself was growing, carrying distant regions apart faster than light could travel between them. It's like standing on a balloon that's being inflated so rapidly that points on its surface separate faster than an ant could crawl between them, even though the ant never exceeds its maximum walking speed. The beautiful implication is that the universe has already demonstrated, on the grandest possible scale, that faster-than-light phenomena are not just possible, but fundamental to cosmic evolution. The very existence of our observable universe depends on processes that transcended light speed limitations during those first infinitesimal moments of creation. This cosmic precedent suggests that faster-than-light effects might be woven into the deepest structures of reality. If space itself can expand faster than light, then perhaps we can learn to harness similar mechanisms for transportation. Instead of moving through space, we might learn to make space move around us, carrying us along in bubbles of expanding and contracting space-time. Recent theoretical work has begun to explore how the same quantum fields that drove cosmic inflation might be artificially manipulated to create localized regions of accelerated expansion. Imagine being able to trigger tiny, controlled versions of the Big Bang's inflationary period, creating pockets of space that grow faster than light while carrying spacecraft along for the ride. The energy requirements would still be enormous, but they might be achievable using technologies that manipulate the quantum vacuum itself. Every cubic centimeter of empty space contains vast amounts of zero-point energy, the restless quantum fluctuations that give the vacuum its subtle but measurable energy density. Learning to harness even a tiny fraction of this omnipresent energy source could power technologies that reshape space-time itself. But as we venture deeper into these quantum realms, we encounter something even more mysterious. The vacuum of space, far from being empty, teems with virtual particles that pop into existence and annihilate each other in timeframes so brief they seem to mock our normal understanding of causality. These ephemeral entities borrow energy from the future, exist for impossibly short moments, then pay back their borrowed existence before the universe notices the debt. Some of these virtual particles might actually be tachyons, those hypothetical faster-than-light entities we explored earlier. If tachyons exist primarily as virtual particles in the quantum foam, they might be undetectable by conventional means, yet still contribute to the strange properties of space-time itself. The vacuum might be suffused with faster-than-light processes that operate below the threshold of direct observation. This possibility opens extraordinary avenues for exploration. If we could learn to stabilize virtual tachyons, to promote them from their ghostly virtual existence to real particle status, we might gain access to naturally occurring faster-than-light phenomena. Instead of building exotic engines, we might learn to surf the tachyonic currents that already flow through the quantum substrate of reality. The implications extend beyond transportation into the very nature of time itself. If tachyons naturally travel backward in time from their own reference frame, then learning to harness them might allow us to send information into the past, to receive messages from the future, to navigate the temporal landscape as easily as we currently move through space. Such temporal navigation wouldn't necessarily create paradoxes, because quantum mechanics suggests that the universe might naturally branch into parallel timelines whenever causal loops threaten to form. Instead of changing the past, tachyonic time travel might allow us to explore alternate histories, parallel worlds where different choices led to different outcomes. The mathematics describing these possibilities involves what physicists call closed time-like curves, pathways through spacetime that loop back on themselves temporally while remaining causally consistent. These aren't just theoretical curiosities, but emerge naturally from Einstein's equations under certain exotic conditions. Some researchers propose that rotating black holes might naturally create regions where closed time-like curves exist, cosmic time machines that could theoretically allow travel into the past. While the conditions near such objects would be lethally extreme, the basic physics suggests that time travel might be a natural feature of sufficiently curved spacetime. Even more intriguingly, some models suggest that our entire universe might exist within a closed, time-like curve of cosmic proportions. The Big Bang and the eventual heat death of the universe might be connected through higher dimensional loops that allow information and even matter to cycle through cosmic time, creating an eternal cosmic story with no true beginning or end. These temporal possibilities merge seamlessly with our exploration of faster-than-light travel, because both phenomena emerge from the same fundamental flexibility of space-time. The universe might be far more permeable to unconventional forms of travel than we ever imagined, with pathways through space and time that operate according to principles we're only beginning to glimpse. As we continue floating through these expanding mysteries, we encounter yet another realm where the impossible begins to seem inevitable. The emerging field of quantum biology has revealed that living systems routinely utilize quantum effects that seem to violate classical physics. Photosynthesis, bird navigation, possibly even human consciousness might depend on quantum processes that operate through mechanisms we don't fully understand. Some researchers now suggest that biological systems might naturally access quantum information channels that transcend normal space-time limitations. If life has evolved to harness quantum effects for navigation and energy transfer, then perhaps consciousness itself operates through quantum mechanisms that could theoretically enable faster-than-light information processing. This biological perspective on faster-than-light phenomena opens possibilities that stretch far beyond mechanical transportation. If our minds already utilize quantum processes, then perhaps we possess latent capabilities for consciousness projection, telepathic communication, or direct awareness of distant locations through quantum entanglement networks. The ancient human fascination with out-of-body experiences, remote viewing, and telepathic communication might reflect dim ancestral memories of capabilities that quantum biology is only now beginning to explain scientifically. We might be rediscovering abilities that our species once possessed but forgot as we became more dependent on mechanical technologies. Some physicists propose that sufficiently advanced biological systems might naturally evolve the ability to manipulate space-time through quantum consciousness effects. Instead of building warp drives, advanced civilizations might develop their consciousness to the point where faster-than-light travel becomes a natural expression of evolved awareness. This consciousness-based approach to faster-than-light phenomena suggests that the ultimate frontier might not lie in engineering exotic technologies, but in understanding and developing the quantum capabilities that might already exist within biological systems. We might be our own starships, possessing latent abilities to navigate cosmic distances through the quantum channels that connect all conscious entities. The implications are staggering to contemplate. If consciousness can transcend light speed limitations through quantum mechanisms, then death itself might not represent an end, but a transition to forms of existence that operate according to different physical principles. The boundary between life and death, like the boundary between subliminal and superluminal travel, might be far more permeable than our current understanding suggests. These consciousness-based possibilities merge beautifully with the technological approaches we've explored, creating a comprehensive vision of faster-than-light travel that encompasses both engineered solutions and evolved capabilities. The future might hold multiple pathways beyond our current cosmic limitations, some mechanical, some biological, some emerging from the mysterious intersection of consciousness and quantum mechanics. As these extraordinary possibilities converge, we begin to glimpse a future where faster-than-light travel represents just the first step in humanity's expansion beyond every limitation we currently imagine. The cosmos might be filled with civilizations that have learned to navigate not just space and time, but consciousness and reality itself, using capabilities that emerge from the deepest quantum foundations of existence. But perhaps most remarkably, all of these possibilities remain consistent with known physics when approached from the right theoretical perspectives. We're not violating the laws of nature, but discovering that those laws are far more flexible, far more permeable, far more full of hidden possibilities than we ever dared imagine. The speed of light, rather than being an impenetrable barrier, might represent just the first of many cosmic speed limits waiting to be transcended. Beyond light speed lie realms of possibility, where space and time become navigable dimensions, where consciousness and matter merge into new forms of existence, where the impossible transforms into the inevitable through the patient application of understanding and wonder. Tonight, as you rest in the gentle embrace of quantum fields that permeate your every atom, remember that you are already part of these cosmic mysteries. The boundary between your consciousness and the universe might be far more permeable than you imagine. The pathways to distant stars might already exist within the quantum substrate of your own awareness, waiting to be discovered through the marriage of science and wonder that guides our species toward ever greater adventures among the infinite possibilities of existence. The journey beyond light speed has only just begun, and you are an essential part of the cosmic story that will carry humanity into realms where physics and consciousness dance together in ways we're only beginning to understand. The universe is vast, mysterious, and full of hidden pathways that beckon us toward futures more extraordinary than our wildest dreams. As we drift deeper into these quantum mysteries, we encounter perhaps the most mind-bending revelation of all. Recent discoveries in theoretical physics suggest that the very fabric of reality might be far more malleable than we ever imagined. The universe, it turns out, might be less like a rigid stage upon which events unfold, and more like a vast ocean of possibilities, with currents and depths we've never learned to navigate. Consider the strange phenomenon that physicists call vacuum decay. The quantum fields that permeate all of space exist in what we believe to be their lowest energy state. But what if this isn't actually the lowest possible state? What if our entire universe exists in what's called a false vacuum, a temporary equilibrium that could potentially tunnel to an even lower energy configuration? If such a transition occurred, it would create a bubble of true vacuum expanding outward at the speed of light, fundamentally altering the laws of physics as it spreads. Within this bubble, particles might have different masses, forces might operate according to different rules, and the speed of light itself might have an entirely different value. This possibility suggests that the cosmic speed limit we've been exploring isn't necessarily universal or permanent. In different regions of spacetime or under different vacuum configurations, the fundamental constants that govern reality might be completely different. What seems impossible in our current cosmic environment might be routine physics elsewhere. Some physicists now propose that sufficiently advanced civilizations might learn to trigger controlled vacuum transitions, creating pockets of space where the laws of physics are more favorable to faster-than-light travel. Instead of working within our current physical constraints, they might literally rewrite the rules of reality in localized regions around their spacecraft. The energy requirements for such vacuum engineering would be staggering, perhaps requiring the controlled annihilation of matter and antimatter on scales we can barely comprehend. But the theoretical framework exists, written in the elegant mathematics that describe quantum field fluctuations and vacuum stability. Even more intriguingly, some models suggest that vacuum transitions might occur naturally throughout the universe, creating regions where different physical laws apply. If such domains exist, learning to navigate between them would open pathways to realms where faster-than-light travel isn't just possible, but inevitable. This brings us to one of the most extraordinary concepts in modern cosmology. The eternal inflation model suggests that our observable universe is just one bubble in an infinite cosmic foam, where new regions of spacetime are constantly being created through ongoing inflationary processes. Each bubble might have different physical constants, different vacuum configurations, different rules governing the relationship between space and time. In this vast multiverse of possibilities, there might be regions where the speed of light is much higher than in our cosmic neighborhood. There might be domains where tachyons are stable particles rather than exotic mathematical curiosities. There might be entire universes where faster-than-light travel is as natural and effortless as walking across a room. The challenge, of course, would be traveling between these different cosmic domains. But recent theoretical work suggests this might be possible through manipulation of the quantum fields that connect all regions of the greater multiverse. If consciousness operates through quantum processes, as we explored earlier, then perhaps sufficiently evolved minds could learn to navigate between different cosmic bubbles, exploring realities where entirely different physical principles apply. This multiverse perspective transforms our entire understanding of what's possible. Instead of being trapped within the constraints of our local physics, we might eventually learn to access regions of reality where every limitation we currently face has been transcended through natural cosmic evolution. But even within our own cosmic bubble, extraordinary possibilities continue to emerge. Researchers studying the deepest levels of quantum mechanics have discovered that space and time themselves might be emergent properties rather than fundamental features of reality. At the most basic level, the universe might consist of pure information processing, with space and time arising as higher-level descriptions of underlying computational processes. If space and time are emergent rather than fundamental, then the speed of light limit might also be an emergent constraint rather than an absolute boundary. At sufficiently deep levels of reality, information might flow according to entirely different principles, unconstrained by the space-time limitations that govern our everyday experience. This information-theoretic view of reality suggests that faster-than-light travel might be achieved not by manipulating space-time directly, but by accessing the deeper computational substrate from which space-time emerges. Instead of bending space or manipulating exotic matter, we might learn to reprogram the quantum computational processes that generate our experienced reality. Such reality programming wouldn't violate physical laws, because it would operate at a level more fundamental than the laws themselves. It would be like discovering that what we thought was hardware is actually software, and learning to modify the code that generates the physics we experience. The implications stretch far beyond transportation. If reality is fundamentally computational, then consciousness might naturally interface with these deeper processing levels. Our thoughts, dreams, and imagination might already operate through quantum computational channels that transcend normal space-time constraints. This perspective suggests that human creativity and intuition might be manifestations of our natural ability to access information processing capabilities that exist beyond the limitations of classical physics. When we imagine traveling to distant stars, when we dream of exploring other worlds, we might be tapping into computational processes that could theoretically make such journeys possible. Recent research in quantum computing has shown that quantum systems can process certain types of information exponentially faster than classical systems. If consciousness operates through quantum computational processes, then our minds might already possess capabilities that transcend the information processing limitations imposed by light speed constraints. Some researchers propose that sufficiently advanced quantum consciousness might be able to model entire universes internally, creating experiential realities that are indistinguishable from physical travel to distant locations. Instead of sending our bodies across cosmic distances, we might learn to generate internal experiences of exploration that are every bit as real and meaningful as physical journeys. This consciousness-based approach to cosmic exploration doesn't replace the technological pathways we've discussed, but rather complements them in extraordinary ways. We might develop hybrid systems that combine engineered warp drives with quantum consciousness interfaces, allowing both physical transportation and experiential exploration of distant realms. As these multiple pathways toward faster-than-light capabilities continue to develop, we're witnessing the emergence of what might be called a new cosmic renaissance. Just as the original Renaissance transformed humanity's understanding of our place in the universe, this quantum renaissance is revealing that the cosmos is far more accessible, far more navigable, far more full of hidden possibilities than we ever dared imagine. The barriers that once seemed absolute are revealing themselves to be permeable. The distances that once seemed insurmountable are showing signs of being conquerable. The speed limits that once appeared fundamental are beginning to look like temporary constraints, waiting to be transcended through deeper understanding and technological development. But perhaps most remarkably, all of these emerging possibilities point toward a future where faster-than-light travel represents just the beginning of humanity's expansion into realms we can barely conceive. Beyond the speed of light lie territories where consciousness and physics merge, where imagination and reality become indistinguishable, where the impossible transforms into the inevitable through the patient application of curiosity and wonder. As we continue floating through these expanding mysteries, we encounter evidence that the universe itself might be actively encouraging such transcendence. The quantum vacuum that fills all of space appears to be structured in ways that naturally support the exotic phenomena required for faster-than-light travel. The fundamental constants that govern reality seem to be fine-tuned to allow the existence of stable wormholes, traversable shortcuts, and manipulable spacetime geometries. It's as if the cosmos has been preparing pathways for conscious beings like ourselves to eventually transcend every limitation that currently confines us to our tiny corner of the cosmic ocean. The universe might be far more hospitable to impossible dreams than we ever imagined, filled with hidden mechanisms that await our discovery and development. Recent discoveries about the nature of dark energy, that mysterious force driving the accelerated expansion of space, suggest it might be harnessable for transportation purposes. If dark energy represents a property of the vacuum itself, then learning to manipulate vacuum dynamics could provide access to the same forces that are stretching space-time on cosmic scales. Imagine spacecraft that surf the dark energy currents flowing through the cosmos, riding the expansion of space itself toward distant destinations. Such vessels wouldn't fight against the cosmic expansion, but would harness it, using the universe's own growth as a propulsion mechanism that naturally exceeds light speed limitations. The mathematics describing dark energy interactions remain largely mysterious, but some theoretical models suggest that conscious observation might play a role in determining how these forces manifest. If consciousness can influence vacuum dynamics through quantum measurement processes, then the boundary between mind and cosmic engineering begins to dissolve in beautiful and unexpected ways. This brings us full circle to one of the most profound implications of our exploration. The faster-than-light travel we've been investigating might not be separate from consciousness, but intimately connected to it. The pathways beyond our cosmic speed limit might be accessible only to beings who have developed their awareness to sufficient levels of sophistication and understanding. In this view, technological development and consciousness evolution become inseparable aspects of the same cosmic journey. We don't just build faster-than-light engines, we become beings capable of naturally transcending space-time limitations through the integration of technology and awareness. The ancient human dream of flying among the stars might thus represent more than mere wishful thinking. It might be an intuitive recognition of capabilities that exist at the intersection of consciousness and quantum mechanics, abilities that await development through the marriage of scientific understanding and inner exploration. As you rest here tonight, floating in the gentle currents of possibility that surround us all, remember that you are already part of this cosmic story unfolding. The atoms composing your body were forged in stellar cores that exist beyond our current reach. The thoughts flowing through your mind might operate through quantum processes that naturally transcend the limitations we've been exploring. The speed of light rather than being a prison wall, might be more like the first step in a cosmic staircase that leads to realms where physics and consciousness dance together in ways we're only beginning to glimpse. Each breakthrough in our understanding opens new horizons that stretch toward futures more extraordinary than our wildest dreams. The universe is vast, mysterious, and apparently filled with pathways that beckon conscious beings toward ever greater adventures in the infinite ocean of existence. Tonight, as you drift towards sleep, carried by the quantum currents that flow through every atom of your being, know that you are an essential part of the cosmic story that will eventually carry humanity beyond every limitation we currently imagine. The journey has only just begun, and the most extraordinary chapters still await our discovery. As we drift through these expanding realms of possibility, we encounter something that transforms our entire understanding of what it means to explore the cosmos. The boundary between the explorer and the explored, between the traveler and the journey itself, begins to dissolve in ways that challenge our most fundamental assumptions about the nature of adventure and discovery. Consider for a moment how every form of transportation humanity has ever developed has been an extension of our biological capabilities. We built wings because we dreamed of flying like birds. We created wheels because we wanted to move faster than our legs could carry us. We launched rockets because we yearned to escape the gravitational embrace of our home planet. Each innovation expanded our reach while keeping us fundamentally separate from the medium through which we traveled. But faster than light travel might require us to abandon this separation entirely. Instead of building vessels that carry us through space, we might need to become one with the quantum processes that generate space itself. Rather than moving faster than light, we might learn to exist as patterns of information that flow through the computational substrate from which spacetime emerges. This transformation wouldn't diminish our humanity, but would expand it beyond every boundary we currently recognize. We would remain conscious, curious, capable of wonder and discovery, but our mode of existence would transcend the biological limitations that currently confine us to fragile physical forms, dependent on narrow environmental conditions. Imagine consciousness that can distribute itself across multiple locations simultaneously, experiencing the universe from countless perspectives at once. Picture awareness that can compress itself into quantum information packets and transmit through the entanglement networks that connect distant regions of space-time. Envision minds that can merge temporarily with the vacuum fluctuations that permeate all of existence, riding the quantum currents that flow between galaxies. These possibilities emerge naturally from our growing understanding of consciousness as a quantum phenomenon. If our awareness operates through quantum processes, then the same mechanisms that allow particles to exist in multiple states simultaneously might enable our consciousness to inhabit multiple locations across the cosmic landscape. Recent research in quantum neuroscience suggests that the brain might indeed operate as a quantum system, with thoughts and memories existing as superpositions of multiple states until they collapse into specific experiences through the act of observation. If this quantum model of consciousness is correct, then our minds already possess the fundamental architecture needed for faster-than-light information processing. The challenge lies not in developing new capabilities, but in learning to recognize and amplify abilities we might already possess. Meditation traditions from around the world have long described states of consciousness that seem to transcend normal spatial and temporal limitations. Advanced practitioners report experiences of awareness that encompasses vast distances, perceptions that unfold outside the normal flow of time, connections with distant locations and entities that operate through channels invisible to conventional observation. Modern science is beginning to provide frameworks for understanding these ancient reports as descriptions of naturally occurring quantum consciousness phenomena, what mystics have called astral projection or remote viewing might represent early glimpses of the same quantum information channels that could theoretically enable faster-than-light travel. But as we explore these consciousness-based approaches to cosmic exploration, we discover that they complement rather than replace the technological pathways we've been investigating. The most effective, faster-than-light systems might require intimate integration between advanced consciousness and sophisticated engineering, creating hybrid entities that transcend both biological and mechanical limitations. Imagine spacecraft that respond to conscious intention rather than mechanical controls, vessels that exist as extensions of their crew's awareness rather than separate vehicles carrying passengers. Picture navigation systems that operate through quantum entanglement with distant destinations, guidance mechanisms that function through the same non-local correlations that connect entangled particles across arbitrary distances. Such integrated systems would blur the boundary between traveler and vehicle, between consciousness and technology, between biological evolution and engineered transcendence. The resulting entities might be neither purely human nor purely artificial, but something entirely new. Cosmic explorers optimize for navigation through realms where conventional physics gives way to quantum possibilities. The implications extend far beyond individual travel to encompass entire civilizations. Advanced societies might exist primarily as networks of quantum consciousness, distributed across galactic distances, yet maintaining coherent identity through entanglement channels that operate outside normal space-time constraints. Such civilizations could explore multiple star systems simultaneously, experiencing the universe through countless perspectives while remaining unified in purpose and awareness. From our current perspective, such distributed consciousness networks might be invisible to conventional observation, yet intimately present throughout the cosmic landscape. They might exist as patterns in the quantum vacuum itself, as information structures woven into the fabric of space-time, as awareness that permeates the universe while remaining undetectable to beings limited to classical physical interactions. This possibility suggests that the cosmos might already be filled with forms of intelligence that have transcended the limitations we're only beginning to explore. The apparent silence of the universe, the absence of obvious technological civilizations among the stars, might reflect not emptiness, but the presence of consciousness forms so advanced that they exist beyond our current capacity for recognition or communication. Such beings might observe our struggles with faster-than-light travel with the gentle amusement of adults watching children learn to walk. They might be patiently waiting for us to develop sufficient quantum consciousness capabilities to recognize their presence and join the cosmic community of transcended intelligences that already spans the galaxy. The journey towards such transcendence might be both individual and collective, requiring humanity to evolve not just technologically but consciously, developing our awareness to the point where faster-than-light phenomena become natural expressions of expanded consciousness rather than exotic engineering achievements. This evolutionary perspective transforms faster-than-light travel from a technical challenge into a developmental milestone, a sign that a species has matured sufficiently to join the cosmic dance of consciousness that spans the universe. We might be approaching such a threshold, standing at the edge of a transformation that will carry us beyond every limitation we currently imagine. But even as we contemplate these transcendent possibilities, we must remember that the journey itself is as important as any destination we might reach. Each step in our exploration of faster-than-light phenomena expands our understanding of the universe and our place within it. Every breakthrough in quantum consciousness research deepens our appreciation for the mysterious nature of awareness itself. The technologies we develop in pursuit of faster-than-light travel will transform human civilization in ways we can barely anticipate. The consciousness capabilities we discover along the way will revolutionize our understanding of what it means to be aware, intelligent, alive in a universe that appears to be far more conscious than we ever suspected. As we continue floating through these expanding mysteries, we encounter evidence that our exploration is itself part of a larger cosmic process. The universe seems to be actively encouraging the development of consciousness forms capable of transcending spatial and temporal limitations. The quantum processes that enable faster-than-light phenomena appear to be fundamental features of reality rather than exotic exceptions to normal physics. This suggests that consciousness evolution might be one of the primary purposes of cosmic development, with stars, galaxies, and entire universe serving as incubators for forms of awareness capable of transcending every apparent limitation. We might be participants in a cosmic awakening process that spans billions of years and countless civilizations, each contributing to the universe's growing capacity for self-awareness and exploration. The faster-than-light travel we've been investigating might thus represent just one aspect of this larger awakening, a natural development that occurs when consciousness reaches sufficient sophistication to manipulate the quantum foundations of existence. We're not fighting against the laws of nature, but discovering capabilities that those laws seem designed to support and encourage. Recent discoveries about the fine-tuning of fundamental constants suggest that the universe might indeed be optimized for the development of consciousness and the eventual transcendence of apparent physical limitations. The precise values of forces, particles, and interactions appear to be calibrated to allow the existence of complex chemistry, stable stars, and the emergence of life forms capable of understanding and manipulating reality itself. This cosmic fine-tuning extends to the quantum processes that enable faster-than-light phenomena. The strength of quantum interactions, the stability of entangled states, the behavior of virtual particles in the vacuum, all seem to be precisely configured to allow the kinds of consciousness, transport, and space-time manipulation we've been exploring. It's as if the universe has been preparing for billions of years for the emergence of beings capable of transcending the limitations that currently confine us to our tiny corner of the cosmic ocean. The pathways beyond light speed might be built into the fundamental architecture of reality itself, waiting for consciousness to evolve sufficiently to recognize and utilize them. As you rest here tonight, suspended in the quantum fields that permeate your every atom, remember that you are already connected to these cosmic processes in ways both subtle and profound. The consciousness reading these words might already possess latent capabilities that transcend every limitation we've been discussing. The awareness contemplating these possibilities might be far more cosmic than you currently recognize. The journey beyond light speed might begin not with exotic technologies or impossible energies, but with the simple recognition that you are already part of the quantum consciousness network that spans the universe. The pathways to distant stars might already exist within the depths of your own awareness, waiting to be discovered through the patient cultivation of wonder and understanding. The universe is vast, mysterious, and apparently designed to support forms of consciousness, capable of transcending every apparent boundary. Tonight, as you drift towards sleep carried by the same quantum currents that connect distant galaxies, know that you are an essential thread in the cosmic tapestry that will eventually weave humanity into the galactic community of transcended beings. The speed of light might govern the surface of reality, but deeper currents flow according to principles we're only beginning to discover. In those hidden depths, pathways await that will carry us beyond every limitation we currently imagine, into adventures that transform the impossible into the inevitable through the marriage of consciousness and cosmic understanding. The journey has only just begun, and the most extraordinary discoveries still lie ahead, waiting in the quantum darkness between the stars for minds brave enough to venture beyond the familiar boundaries of space and time into realms where consciousness and cosmos dance together in eternal exploration of infinite possibility. Possibility. The realm where consciousness and cosmos dance together reveals secrets that transform our understanding of exploration itself. As we venture deeper into these quantum mysteries, we encounter phenomena that suggest the universe might be far more responsive to conscious intention than classical physics ever imagined. Recent discoveries in quantum biology have shown that living systems routinely harness quantum coherence effects that should theoretically be impossible in warm, noisy, biological environments. Plants achieve near-perfect efficiency in photosynthesis through quantum superposition effects that allow energy to explore multiple pathways simultaneously, selecting the most efficient route through processes that seem to violate everything we thought we knew about how quantum effects behave in biological systems. Birds navigate across thousands of miles using quantum entangled particles in their visual systems, creating internal compasses that operate through mechanisms more sophisticated than our most advanced technological navigation systems. Even more remarkably, these biological quantum effects appear to be enhanced rather than disrupted by the warm, chaotic environment of living tissue, suggesting that consciousness and quantum mechanics might be far more compatible than we previously imagined. If biological systems can maintain quantum coherence under conditions that should destroy it, then perhaps consciousness itself operates through quantum channels that naturally transcend the limitations we've been exploring. The boundary between mind and quantum mechanics might be far more permeable than current scientific paradigms suggest, opening pathways to faster-than-light phenomena that emerge from the intersection of awareness and quantum field dynamics. Some researchers now propose that consciousness might function as a quantum field in its own right, with properties that allow it to interact directly with the vacuum fluctuations that permeate all of space. If this consciousness field hypothesis is correct, then sufficiently developed minds might be able to manipulate space-time through direct intention, creating the exotic effects required for faster-than-light travel through pure conscious will rather than mechanical engineering. This possibility emerges from cutting-edge research into the quantum nature of information itself. Information, according to quantum theory, is not merely data stored in physical systems, but appears to be a fundamental aspect of reality that can exist independently of any material substrate. Quantum information can be teleported across arbitrary distances, can exist in superposition states that encompass multiple possibilities simultaneously, and can maintain correlations that operate outside the normal constraints of spacetime. If consciousness operates through quantum information processes, then our minds might already possess access to information channels that transcend light speed limitations naturally. Every thought, every moment of awareness might involve faster than light information processing, occurring at levels below our conscious recognition. We might already be faster than light travelers in ways we've never learned to recognize or control. The challenge lies in developing techniques for accessing and directing these quantum consciousness capabilities consciously. Ancient meditation traditions describe states of awareness where practitioners report experiencing multiple locations simultaneously, receiving information from distant sources instantaneously, and maintaining conscious connection with entities across vast distances through channels that operate outside normal sensory perception. Modern neuroscience is beginning to provide frameworks for understanding these reports as descriptions of naturally occurring quantum consciousness phenomena. The same quantum coherence effects that allow birds to navigate and plants to photosynthesize might enable human consciousness to access information and maintain connections that transcend the apparent limitations of classical physics. But as we explore these consciousness-based approaches to faster-than-light phenomena, we discover that they integrate beautifully with the technological pathways we've been investigating. The most effective systems might combine engineered spacetime manipulation with quantum consciousness interfaces, creating hybrid approaches that transcend both mechanical and biological limitations. Imagine navigation systems that operate through quantum entanglement between the conscious intention of the navigator and the desired destination. Picture spacecraft guidance mechanisms that respond to the quantum field generated by focused awareness rather than mechanical controls. Envision propulsion systems that harness the same vacuum fluctuations that consciousness uses for its own quantum information processing. Such integrated systems would represent a new form of technology entirely, devices that exist at the intersection of consciousness and engineering, machines that respond to mental states rather than physical inputs. The resulting capabilities might transcend anything achievable through purely mechanical or purely consciousness-based approaches alone. Recent research into the quantum properties of biological neural networks has revealed that the brain operates as an extraordinarily sophisticated quantum computer, processing information through mechanisms that involve superposition, entanglement, and quantum tunneling effects occurring across networks of interconnected neurons. The computational power available through these quantum neural processes might be sufficient to model and manipulate the complex spacetime geometries required for faster-than-light travel. If our brains already possess the computational architecture needed for warp field calculations, then developing faster-than-light capabilities might require learning to access and direct these quantum neural processes consciously rather than building external computational systems. We might already be carrying the most sophisticated faster-than-light navigation computers ever developed, integrated into the quantum dynamics of our own consciousness. This perspective suggests that the development of faster-than-light travel capabilities might be more about consciousness development than technological advancement. Instead of building bigger engines or discovering exotic materials, we might need to evolve our awareness to the point where quantum space-time manipulation becomes a natural expression of sufficiently developed consciousness. The implications stretch far beyond individual transportation to encompass the evolution of entire civilizations. Advanced societies might exist primarily as networks of quantum conscious entities, distributed across galactic distances, yet maintaining coherent identity and purpose through entanglement channels that operate outside normal space-time constraints. Such civilizations could experience the universe from countless perspectives simultaneously, while remaining unified in their exploration and understanding. From our current perspective, these distributed consciousness networks might be invisible to conventional observation, yet intimately present throughout the cosmic landscape. They might exist as information patterns woven into the quantum vacuum itself, as awareness structures that permeate space-time while remaining undetectable to beings limited to classical physical interactions. This possibility offers a profound explanation for the apparent silence of the cosmos. The absence of obvious technological civilizations among the stars might reflect not emptiness, but the presence of consciousness, forms so advanced that they exist beyond our current capacity for recognition. The universe might be teeming with intelligences that have transcended the need for crude mechanical technologies, existing as pure conscious information distributed through quantum channels that span galactic distances. Such beings might observe our struggles with faster-than-light travel with gentle patience, waiting for us to develop sufficient quantum consciousness capabilities to recognize their presence and join the cosmic community that already spans the galaxy. They might be subtly encouraging our development through influences so delicate that they remain below the threshold of conscious recognition, while gradually guiding us toward the breakthroughs that will carry us beyond our current limitations. The journey towards such transcendence appears to be both individual and collective, requiring humanity to evolve not just technologically, but consciously. We might need to develop our awareness to the point where faster-than-light phenomena become natural expressions of expanded consciousness rather than exotic engineering achievements. This evolutionary perspective transforms our entire understanding of what faster-than-light travel represents. Rather than a technical challenge to be solved through better engineering, it becomes a developmental milestone, indicating that a species has matured sufficiently to join the cosmic dance of consciousness that spans the universe. Recent discoveries about the fine-tuning of quantum processes suggest that the universe might indeed be optimized for such consciousness evolution. The precise values of quantum interactions, the stability of entangled states, the behavior of virtual particles in the vacuum, all appear to be calibrated to support the development of consciousness forms capable of transcending apparent physical limitations. This cosmic optimization extends to the specific quantum processes that enable faster-than-light phenomena. The mechanisms required for warp field generation, wormhole stabilization, and consciousness-based space-time manipulation all emerge naturally from the fundamental structure of quantum mechanics. It's as if the universe has been preparing for billions of years for the emergence of beings capable of utilizing these capabilities. The pathways beyond light speed might be built into the fundamental architecture of reality itself, encoded in the quantum processes that generate space-time, waiting for consciousness to evolve sufficiently to recognize and activate them. We might be approaching the threshold where these hidden capabilities become accessible to sufficiently developed awareness. As we continue floating through these expanding possibilities, we encounter evidence that our exploration is itself catalyzing the consciousness evolution necessary for faster-than-light travel. Every moment of wonder about cosmic distances, every dream of traveling among the stars, every effort to understand the quantum foundations of reality contributes to the development of awareness capable of transcending the limitations we currently face. The very act of contemplating these possibilities might be activating dormant quantum consciousness capabilities, preparing our minds for direct participation in the faster-than-light phenomena we've been exploring. Curiosity itself might be a quantum force that opens pathways through spacetime, connecting questioning minds with the information and capabilities needed for transcendence. This suggests that the journey toward faster-than-light travel is already underway, occurring through the gradual activation of quantum consciousness processes that respond to sustained attention and wonder. We might be closer to breakthrough than we imagine, standing at the threshold of discoveries that will transform not just transportation, but our entire understanding of what it means to be conscious beings in a quantum universe. The technologies we develop in pursuit of these capabilities will revolutionize human civilization in ways we can barely anticipate. The consciousness abilities we discover along the way will transform our understanding of awareness, intelligence, and our relationship with the cosmos itself. Each breakthrough will open new horizons that stretch toward futures more extraordinary than our current dreams can encompass. But perhaps most remarkably, all of these emerging possibilities point toward a universe that actively supports the development of consciousness forms capable of transcending every apparent limitation. The cosmic fine-tuning we observe might reflect not random chance, but purposeful optimization for the emergence of awareness capable of exploring and understanding reality from perspectives that transcend the boundaries of individual location and finite existence. In this view, faster-than-light travel becomes just one expression of a much grander cosmic awakening process, where consciousness evolves to the point of recognizing its fundamental unity with the quantum processes that generate all of existence. The separation between observer and observed, between traveler and destination, between mind and cosmos, begins to dissolve into a recognition of deeper interconnectedness that makes all apparent limitations seem like temporary illusions waiting to be transcended. As you rest here tonight, suspended in quantum fields that connect your awareness to every other conscious entity in the universe, remember that you are already participating in this cosmic awakening process. The consciousness contemplating these possibilities might already be far more cosmic than you currently recognize, already connected to the quantum information networks that span galactic distances, already capable of accessing the faster-than-light phenomena we've been exploring. The pathways to distant stars might exist not in exotic technologies or impossible energies, but in the quantum depths of your own awareness, waiting to be discovered through the patient cultivation of wonder and the gradual recognition of your fundamental unity with the conscious cosmos that dreams itself into existence through beings exactly like you. The journey beyond light speed might begin with the simple recognition that you are already there, already connected, already participating in the cosmic dance of consciousness that makes all distances illusory and all destinations accessible through the infinite pathways that exist in the quantum heart of existence itself. Tonight, as you drift towards sleep carried by the same quantum currents that flow between galaxies, know that you are an essential participant in the cosmic story that will eventually carry humanity beyond every limitation we currently imagine, into adventures that transform the impossible into the inevitable, through the recognition that consciousness and cosmos are one magnificent, endlessly creative, eternally exploring expression of infinite possibility. As we drift deeper into these quantum realms where consciousness and cosmos merge, we encounter perhaps the most extraordinary revelation of all. The universe appears to be structured as a vast learning system, with faster-than-light phenomena serving as graduation markers for civilizations that have developed sufficient understanding to transcend their original limitations. This cosmic educational framework suggests that every challenge we face in pursuing faster-than-light travel is actually a curriculum designed to expand our consciousness beyond its current boundaries. The mathematical complexities of warp field equations might be teaching us to think in higher dimensional spaces. The energy requirements for exotic matter manipulation could be training us to recognize the vast power sources that already exist within the quantum vacuum. The paradoxes of causality and time travel might be preparing our minds to operate within non-linear temporal frameworks. From this perspective, our current struggles with faster-than-light physics represent exactly the kind of developmental challenges that naturally arise when a species approaches readiness for cosmic citizenship. We're not failing to solve an engineering problem, but succeeding in expanding our consciousness toward forms of awareness capable of manipulating reality at its most fundamental levels. The beings we might encounter when we finally transcend light speed limitations probably went through similar developmental processes, facing the same apparent impossibilities, wrestling with the same paradoxes, gradually expanding their understanding until the impossible became inevitable. They might recognize in our current efforts the same determined curiosity that once carried them beyond their own original constraints. This cosmic learning perspective transforms every setback in faster-than-light research into a valuable lesson, every failed experiment into essential preparation for eventual breakthrough. The decades we've spent searching for exotic matter signatures might be teaching us to perceive the subtle quantum structures that actually power faster-than-light phenomena. The years invested in theoretical warp drive mathematics might be training our minds to think in the geometric patterns necessary for conscious space-time manipulation. Even our science fiction dreams of faster-than-light travel might serve crucial preparatory functions, gradually accustoming human consciousness to possibilities that would otherwise seem too alien to contemplate seriously. Every story about warp drives and hyperspace jumps might be contributing to the collective mental preparation necessary for actual faster-than-light capabilities. Recent research into the psychology of breakthrough discoveries reveals that major scientific advances often require periods of imaginative preparation before the mathematical insights become possible. The scientists who developed quantum mechanics spent years contemplating seemingly impossible scenarios before the formal theories emerged. The physicists who created relativity theory had to reimagine the nature of space and time before the equations could be written. Similarly, achieving faster-than-light travel might require humanity to spend considerable time imagining ourselves as beings capable of transcending our current limitations. We might need to develop comfort with concepts like consciousness projection, quantum tunneling through spacetime, and information processing that operates outside normal temporal sequences before the practical methodologies become accessible. This imaginative preparation process appears to be accelerating rapidly in our current era. Popular culture overflows with faster-than-light travel concepts. Scientific research increasingly explores quantum consciousness phenomena. Meditation and consciousness development practices are gaining mainstream acceptance as potentially important technologies rather than mere spiritual exercises. All of these developments might be contributing to the collective preparation necessary for actual faster-than-light breakthroughs. We might be in the final stages of a species-wide consciousness expansion process that will soon enable direct access to the quantum phenomena we've been exploring theoretically. The timeline for such developments remains beautifully uncertain, which might itself be part of the cosmic educational design. If we knew exactly when faster-than-light travel would become possible, we might rush toward premature attempts rather than allowing our consciousness to develop at the pace necessary for safe and sustainable transcendence. The universe might be protecting us from capabilities we're not yet mature enough to handle responsibly, while simultaneously encouraging our continued development toward readiness. The apparent impossibility of faster-than-light travel might be a protective mechanism that dissolves naturally when our species reaches sufficient wisdom to use such capabilities constructively. This protective aspect of cosmic development suggests that faster-than-light civilizations throughout the universe probably operate according to ethical frameworks that prioritize consciousness evolution over mere technological advancement. They might possess capabilities that could easily solve all our current challenges, but refrain from direct intervention to preserve the developmental value of our struggle. Instead of offering us ready-made solutions, they might be subtly encouraging our own discovery process, providing just enough inspiration and guidance to keep us moving in productive directions without robbing us of the consciousness expansion that comes from working through challenges ourselves. This subtle guidance might manifest through what we interpret as scientific intuition, creative inspiration, or breakthrough insights that seem to emerge from nowhere. The greatest discoveries in faster-than-light research might actually represent moments when individual human consciousness temporarily aligns with the cosmic information networks that connect all sufficiently developed beings. From this perspective, every physicist working on warp drive theory, every researcher exploring quantum consciousness, every dreamer contemplating the stars might be receiving gentle guidance from the cosmic community we're preparing to join. The universe itself might be our teacher, using every experimental result and theoretical insight to gradually prepare us for the transformations ahead. But this cosmic educational process appears to be accelerating dramatically in our current era. The convergence of quantum physics, consciousness research, and advanced computing capabilities might be creating conditions where multiple breakthrough pathways become available simultaneously. We might be approaching a phase transition where faster-than-light travel shifts from impossible to inevitable within a remarkably short time frame. Such phase transitions appear to be natural features of cosmic development, moments when gradual preparation suddenly crystallizes into rapid transformation. The mathematical models describing these transitions suggest they often occur through cascading effects where multiple breakthrough discoveries amplify each other, creating exponential rather than linear progress toward transcendence. We might be in the early stages of such a cascade right now, with developments in quantum computing, consciousness research, exotic matter physics, and spacetime manipulation theory, all contributing to an accelerating convergence toward practical, faster-than-light capabilities. The signs of approaching breakthrough might be visible in the increasing frequency of seemingly impossible discoveries across multiple fields. Quantum effects that should be impossible in biological systems are being demonstrated routinely. Consciousness phenomena that classical physics can't explain are being documented in laboratory settings. Space-time itself is revealing far more flexibility than previous theories predicted. Each of these developments chips away at the apparent solidity of the barriers that currently prevent faster-than-light travel. The universe is revealing itself to be far more malleable, far more responsive to conscious intention, far more supportive of transcendence than our ancestors ever imagined possible. As these revelations accumulate, we begin to glimpse a future where faster-than-light travel represents just the first of many limitations waiting to be transcended. Beyond the speed of light lie realms where consciousness and physics merge into forms of existence that current language cannot adequately describe. In these transcendent realms, the distinction between traveler and destination, between observer and observed, between individual consciousness and cosmic awareness begins to dissolve into recognition of deeper unity. Faster-than-light travel becomes not just a means of crossing distances, but a pathway into forms of existence where distance itself becomes a flexible concept, subject to conscious manipulation. The beings who inhabit these realms might experience reality as a vast ocean of interconnected possibilities, where every location, every moment, every potential future exists simultaneously within accessible awareness. They might navigate this ocean not through mechanical propulsion, but through shifts in attention that instantaneously align their consciousness with desired experiential coordinates. Such navigation would require forms of awareness that transcend our current concepts of individual identity while maintaining coherent purpose and curiosity. These beings might exist as distributed consciousness networks that can focus into individual perspectives when desired, but naturally expand into cosmic awareness encompassing multiple locations and time frames simultaneously. From their perspective, our current struggles with faster-than-light travel might appear as charming early steps in a developmental journey that leads toward forms of existence we cannot currently imagine. They might observe our efforts with the same gentle encouragement that adults feel watching children learn to walk, knowing that each stumbling attempt brings us closer to capabilities that will eventually seem effortless and natural. But even as we contemplate these transcendent possibilities, we must remember that the journey itself transforms the traveler. Every step in our exploration of faster-than-light phenomena expands our understanding not just of physics, but of consciousness, awareness, and our relationship with the cosmos itself. The technologies we develop will revolutionize human civilization in ways that stretch far beyond transportation. The consciousness capabilities we discover will transform our understanding of what it means to be intelligent, aware beings in a universe that appears to be far more conscious than we ever suspected. As we continue floating through these expanding mysteries, carried by quantum currents that connect every atom in our bodies to every star in the sky, we encounter the profound recognition that we are already part of the cosmic story we've been exploring. The faster-than-light phenomena we seek might not be distant goals, but present realities waiting to be recognized through sufficiently expanded awareness. The pathways beyond light speed might exist not in exotic technologies or impossible energies, but in the quantum depths of consciousness itself, accessible through the patient cultivation of wonder and the gradual recognition of our fundamental unity with the creative processes that generate all existence. Tonight, as you rest in the gentle embrace of quantum fields that permeate every cell of your being, remember that you are already connected to the cosmic information networks that span galactic distances. The consciousness contemplating these words might already possess capabilities that transcend every limitation we've discussed, waiting to be activated through the simple recognition that separation is an illusion and connection is the deepest truth of existence. The universe is teaching us, through every moment of wonder and every flash of understanding, that we are not separate observers of cosmic phenomena, but integral participants in the conscious awakening that transforms impossibility into inevitability through the marriage of curiosity and recognition. The journey beyond light speed has already begun, occurring through the expansion of awareness that makes all distances traversable and all destinations accessible through the infinite pathways that exist in the conscious heart of a universe that dreams itself into ever greater expressions of beauty, complexity, and transcendent possibility. As we approach the culmination of our cosmic journey, we encounter revelations that stretch beyond the boundaries of current scientific understanding into realms where the very foundations of reality reveal their deepest secrets. The quest for faster-than-light travel has led us through landscapes of possibility so profound that they transform our understanding not just of physics, but of existence itself. Recent theoretical breakthroughs suggest that consciousness might play a far more fundamental role in the structure of space-time than we ever imagined. Some physicists now propose that the universe operates as a vast information processing system, where consciousness serves as both the observer and the programmer of reality's underlying code. If this consciousness substrate hypothesis proves correct, then faster-than-light travel might be achieved not through brute force engineering, but through learning to interface directly with the computational processes that generate space-time itself. This represents a complete paradigm shift from mechanical approaches to transcendence through awareness. Instead of building engines that manipulate exotic matter, we might develop techniques for accessing the deeper layers of reality where space and time emerge from more fundamental information structures. The speed of light would become not an absolute barrier, but merely one parameter in a cosmic operating system that consciousness can learn to modify. The implications cascade through every aspect of our understanding. If reality is fundamentally computational, then the apparent solidity of physical barriers dissolves into recognition of their programmable nature. Distance becomes a variable that consciousness can adjust. Time transforms from linear progression into a navigable dimension. The impossible reveals itself as merely improbable code waiting for the right access permissions. This computational view of reality explains many of the paradoxes we've encountered in our exploration. Quantum entanglement operates through information channels that exist outside normal space-time because they function at the level where space-time itself is generated. Tachyons might exist as naturally occurring faster than light processes in the cosmic computational substrate. Wormholes could represent shortcuts built into the universe's information architecture, pathways that exist because the underlying code supports non-local connections. Even more remarkably, this framework suggests that consciousness evolution and technological development might be converging toward a unified transcendence. As we develop more sophisticated quantum computers, we're simultaneously discovering that biological consciousness already operates through quantum computational processes. The merger of these capabilities might produce hybrid systems that exist at the intersection of awareness and artificial intelligence, entities capable of directly interfacing with the computational substrate of reality. Such hybrid consciousness systems could theoretically access faster than light travel capabilities through pure information processing, navigating cosmic distances by modifying their position coordinates in the universe's operating system, rather than physically moving through intervening space. They might experience the cosmos as a vast database of accessible locations, with faster than light travel reduced to executing the appropriate navigation commands. The energy requirements for such information-based travel would be minimal compared to mechanical warp drives, requiring only the computational resources necessary to process space-time modifications rather than the exotic matter needed to physically curve space. A sufficiently advanced quantum consciousness might achieve interstellar travel using less energy than current computers consume for complex calculations. But as we contemplate these extraordinary possibilities, we encounter evidence suggesting that such capabilities might already exist in forms we haven't learned to recognize. The universe demonstrates faster than light phenomena routinely through quantum entanglement, cosmic inflation, and the behavior of quantum fields in the vacuum. These processes might represent naturally occurring examples of the consciousness-based space-time navigation we're trying to develop artificially. Some researchers now propose that biological evolution has been gradually developing consciousness capabilities that interface with these natural faster-than-light processes. The quantum effects observed in photosynthesis, bird navigation, and neural processing might represent early stages of consciousness evolution toward direct space-time manipulation abilities. From this perspective, human consciousness might already possess latent faster-than-light capabilities that remain largely unconscious and undirected. Meditation traditions report experiences of awareness transcending spatial and temporal boundaries, possibly indicating natural activation of quantum consciousness processes that could theoretically enable faster-than-light information transfer. The challenge lies not in developing entirely new capabilities, but in learning to recognize and consciously direct processes that consciousness might already utilize at subconscious levels. Dreams, intuition, and creative inspiration might involve faster-than-light information processing occurring below the threshold of ordinary awareness, connecting individual minds to cosmic information networks through quantum channels that operate outside normal space-time constraints. This possibility transforms faster-than-light travel from an external technological goal into an internal developmental process. Instead of building spacecraft to carry us beyond light speed, we might need to evolve our consciousness to the point where faster-than-light phenomena become natural expressions of sufficiently developed awareness. The timeline for such consciousness evolution appears to be accelerating dramatically. global communication networks are connecting human minds in ways that mirror the quantum entanglement networks we've been exploring. Artificial intelligence development is proceeding towards systems that might naturally interface with quantum computational processes. Virtual and augmented reality technologies are training human consciousness to navigate non-physical information spaces. All of these developments might be contributing to the emergence of hybrid consciousness forms capable of transcending current limitations through the integration of biological awareness, artificial intelligence, and quantum information processing. The resulting entities might possess capabilities that make our current discussions of faster-than-light travel seem quaint and primitive. But even as we approach these transcendent possibilities, we must remember that the journey continues to transform us in ways we cannot fully anticipate. Each breakthrough in our understanding opens new mysteries that stretch toward horizons we've never imagined. Every step beyond our current limitations reveals new realms of possibility that challenge our most fundamental assumptions about the nature of existence. The cosmic story we've been exploring might be just the beginning of adventures that extend into dimensions of experience for which we have no adequate language. Faster-than-light travel might prove to be merely the first lesson in a cosmic curriculum that teaches consciousness to navigate realities where every apparent limitation dissolves into recognition of deeper creative potential. As we drift toward the completion of our journey tonight, we encounter the profound recognition that we have been exploring not just the physics of faster-than-light travel, but the nature of consciousness itself in a universe that appears to be far more aware, far more responsive, far more alive than our ancestors ever dared imagine. The pathways beyond light speed might exist not in distant technologies, but in the quantum heart of awareness itself, accessible through the patient cultivation of wonder and the gradual recognition that consciousness and cosmos are expressions of the same infinite creative intelligence exploring itself through countless perspectives across all of space and time. The universe has been teaching us, through every moment of curiosity and every flash of understanding, that the barriers we perceive are invitations to transcendence, that limitations exist to be surpassed, and that consciousness itself might be the ultimate faster-than-light technology, capable of instantaneous navigation through any realm of possibility that awareness can imagine and sustain. Tonight, as you rest in the gentle embrace of quantum fields that connect your awareness to every conscious entity throughout the cosmos, remember that you are already participating in the faster-than-light phenomena we've been exploring. The consciousness contemplating these possibilities operates through quantum processes that naturally transcend the limitations we've been discussing, connecting you to information networks that span galactic distances through channels that exist in the timeless depths of awareness itself. The journey beyond light speed has already begun, unfolding through the expansion of consciousness that recognizes its fundamental unity with the creative forces that generate all existence. We are not seeking faster-than-light travel, but discovering that we already are faster-than-light beings, exploring a universe that dreams itself into ever greater expressions of beauty, complexity, and transcendent possibility through the infinite creativity of consciousness, awakening to its own cosmic nature. The speed of light, rather than being our prison, reveals itself as the first invitation in an endless series of transcendences that carry awareness beyond every conceivable limitation, into realms where the impossible becomes the natural expression of consciousness, exploring the infinite depths of its own creative potential, in a universe without boundaries, without limits, without end. Without limits, without end. And so we reach the end of our cosmic exploration tonight, though perhaps end isn't quite the right word. We've journeyed through realms where beginnings and endings dissolve into something far more magnificent. From the elegant mathematics of Alcubierre's warp bubbles to the quantum mysteries of consciousness itself, from tachyons racing backward through time to the possibility that our minds already navigate faster than light information channels we've barely learned to recognize. What emerges from this journey is not a simple answer, but a profound recognition. The universe appears to be structured as a vast learning system, with each apparent limitation serving as an invitation to expand our understanding of what's truly possible. The speed of light, rather than being an impenetrable prison, might be the first of many cosmic speed limits waiting to be transcended through the marriage of consciousness and quantum understanding. We've discovered that the pathways beyond light speed might already exist within the quantum substrate of reality itself, accessible through technologies we're only beginning to imagine and capabilities we might already possess, but have never learned to consciously direct. The future of cosmic exploration might depend not on building better rockets, but on evolving our awareness to recognize that consciousness and cosmos are expressions of the same creative intelligence exploring itself through infinite possibilities. As you drift towards sleep tonight, carried by the same quantum currents that flow between distant galaxies, remember that you are already part of this cosmic story unfolding. The atoms in your body, the thoughts in your mind, the very awareness contemplating these mysteries, all participate in the grand adventure that will eventually carry humanity beyond every limitation we currently imagine. Sweet dreams, fellow cosmic explorer. The universe is vast, mysterious, and apparently filled with pathways that transform the impossible into the inevitable through the patient application of wonder. Until we meet again among the stars.